In this video, I'm going to show you how to integrate using the Pythagorean identities. So here we want to compute this integral of 5 sine squared x plus 5 cosine squared x. Initially, this integral seems pretty nasty. We've got some squares of trig functions here. But hold on, look at this, sine squared and cosine squared. Do you know any identities that can be used to simplify sine squared and cosine squared? Well, one thing that comes to mind is the trig identity sine squared plus cosine squared equals 1. Okay, let's see if we can use that here in this integral to simplify the problem. So let's write the integral again, but this time let's factor out a 5 from both the sine squared and the cosine squared. So it'll become integral of 5 times the quantity of sine squared plus cosine squared dx. And now we can simplify this. This inside here, that just comes out to 1. So it's just the integral of 5 times 1 dx. So just the integral of 5 dx. And we know what the integral of 5 is. That's just going to be 5x. So 5x plus our constant of integration, and there we go. That's the result of our integral. So this is going to be our general strategy when we've got some trig functions in the integral and it doesn't seem easy to integrate them one by one. We're just going to look for some trig identities that we can use to simplify the integral into something that is easier to integrate. Here's another example. We want to compute integral of tangent squared x dx, and again this is a trig function raised to a power of 2, so that's going to be pretty difficult to integrate head on. We're going to have to re-express tangent squared x as an expression that's easier to integrate, and we can do that using the Pythagorean identity for trig functions. So starting off the Pythagorean identity, remember it from the last example. That's just sine squared x plus cosine squared x equals 1. And you might say, wait, that doesn't have any tangent in there. How are we going to re-express this tangent? Well, what we can do is we can manipulate this identity to introduce a tangent into there. What is tangent? Well, tangent is just sine over cosine. So to introduce a tangent squared in this identity, let's divide everything by cosine squared. All right, so divide everything by cosine squared, and let's simplify. So sine squared over cosine squared, that's just tangent squared. Great, that's what we wanted, that's good. And then cosine squared over cosine squared, well, clearly that's just 1. And then 1 over cosine squared, though, that's just secant squared. So now we can solve for tangent squared by subtracting 1 and just say tangent squared is equal to secant squared minus 1. Okay, and this is good because we know how to integrate secant squared and we know how to integrate minus 1. So let's go ahead and substitute that back into the integral and then get on with our integration. So we've got integral, instead of tangent squared, we're going to write secant squared x minus 1, equivalent expression, but easier to integrate. And now let's go ahead and integrate. So first of all, integral of secant squared, well, that's just tangent. Derivative of tangent is secant squared, so integral of secant squared is tangent. And then integral of 1 is just x, so tangent of x, then minus x. And then don't forget your constant of integration, plus c. And there you go. That's the integral of tangent squared x. Alright, here is another example. We want to compute the integral of cotangent squared of 4x minus pi. Okay, so this one is also pretty difficult to approach head on. That's a trig function squared with a full expression of x, not just x, but 4x minus pi. So we're going to have to do a little bit of rearranging here in order to express this cotangent squared in terms of something we know how to integrate. So again, why don't we start out with the Pythagorean identity and then try to introduce a cotangent squared. This time I'm going to write the Pythagorean identity using theta, and you'll see why that is in a moment. So sine squared theta plus cos squared theta equals 1. Okay, and if we want to introduce cotangent squared into this identity here, we need to get, well, cotangent is just cosine over sine, so let's divide everything by sine squared theta. That'll make cosine squared theta over sine squared theta into cotangent squared theta. So just simplifying all of this, sine squared over sine squared, that's just 1. Then cosine squared over sine squared, that's cotangent squared. And then 1 over sine squared, that's cosecant squared. Alright, now let's go ahead and solve for cotangent. So cotangent squared theta equals, just subtract the 1 over, you get cosecant squared theta minus 1. And now you'll see why I wanted to write this in terms of theta rather than x. So I wrote it in terms of theta rather than x because I wanted to make it very clear that these identities work not just for x, but also for any argument that might be a full expression of x, like the one here. So what we're going to do is we want to get this expression of x, 4x minus pi, into this identity, because that's what we have. We have cotangent squared of 4x minus pi. So what we're going to do is we're going to say that theta is 4x minus pi. As long as we sub in that same expression for all of the thetas, then it's still a true identity. So let's go ahead and substitute that in, and we get cotangent squared of 4x minus pi is equal to cosecant squared of 4x minus pi minus 1. And we know how to take the integral of cosecant squared and of -1, so this should be smooth sailing from here on out. Great. So let's go ahead and substitute that into our integral now. So cotangent squared now becomes cosecant squared of 4x minus pi, and then minus 1, and all of that is integrated with respect to x. And now we can actually do the integration. Integral of cosecant squared, well, integral of cosecant squared is just cotangent, negative cotangent actually, because derivative of cotangent is negative cosecant squared. Okay, and we're almost there. So cotangent of that inner argument for x minus pi, but because when we differentiate this, the 4x, there will be a chain rule that ends up multiplying this expression by 4. We have to go ahead and divide this expression by 4 to cancel that out. Okay, so this whole expression is the integral of cosecant squared of 4x minus pi, and then minus 1, take the integral of that, you just get minus x. Then don't forget your constant of integration. And why don't we clean this up a little bit? Let's turn that divided by 4 into just a multiplication by 1/4. So negative 1/4 cotangent 4x minus pi minus x plus constant. And bam, we're done. So now we see how to solve some tricky trig integrals using the Pythagorean identities. And in the future, we'll continue to see how to make integral problems easier using trig identities, such as the double angle formulae.